problem number 28. We're showing a bunch of balloons here. Which representation, 1, 2, or 3, shows what balloon Z resembles after each change occurs? So here are 3 changes. So after these changes, what does Z become like? Does it become like 1 or 2 or 3? Okay, let's look at these changes. First we'll look at change A. A quick little note up above which will help us answer these. The 4 gas variables that we're interested in. So if you're talking about a gas, to describe that gas, you need to know the number of moles, the temperature, the pressure, and the volume. Okay, now another note. When you have a gas inside of a balloon, it's at constant pressure. Let me blow this up a little bit more. Okay, gases that are inside of a balloon maintain a constant pressure. So the pressure of the gas inside the balloon matches the pressure of the gas outside the balloon. Now that's true as long as the outside pressure doesn't change. If the outside pressure changes, of course, the inside pressure would change to match it. So let's look at the first one. The first one, A, says the balloon is cooled to a lower temperature. It's cooled to a lower temperature. So you have a gas inside of a balloon. It looks like the balloon's tied. So you're not changing the number of moles of gas. And it's in a balloon, so you're not changing the pressure. The moles and the pressure are held constant. Well, that's a Charles law situation. Charles law describes what happens when the moles and the pressure are held constant. And Charles law says that the temperature is proportional to the volume. When one goes up, the other one goes up. Or when one goes down, the other one goes down. So if you lower the temperature, you're going to also lower the volume. Okay? So looking at Z, it looks like the only choice would be for it to turn into 1. This one has a smaller volume. So Z turns into representation 1. The next one, okay. Some gas leaks out. Some gas leaks out. Well, this time the number of moles of gas is changing, so moles are no longer constant, but it doesn't say anything about the temperature. So let's assume that the temperature is constant and it's still in a balloon. So it's at a constant pressure. So constant temperature and constant pressure. That's an Avogadro's law situation. Avogadro's law says that the volume and the moles are proportional to each other. When one goes up, the other one goes up, and when one goes down, the other one goes down. So if you lose some gas, if you decrease the number of moles of gas, then the volume of the balloon also decreases. So again, it looks like, Z turns into number 1. It turns into a smaller, here it is, a smaller balloon. Okay, the last one. The balloon is allowed to rise to a higher altitude. Now this one's a little tricky. When you're at a higher altitude, the pressure, the atmospheric pressure gets lower, but it also gets colder. So you're at a lower atmospheric pressure and you're at a lower temperature. You remember the pressure inside the balloon matches the pressure outside. So if the balloon floats up in the air and the pressure of the air gets lower, the pressure inside the balloon gets lower as well. And the gas inside the balloon would get colder because air gets colder as you go up in altitude. So what happens to the gas is the pressure is lowered and the temperature is lowered. Okay, now it doesn't say anything about losing or gaining any moles, so we're going to assume that the moles are constant. Well, we can think of lowering the pressure as a a Boyle's law situation. If you lower the pressure, when the pressure goes down, the volume goes up. Okay? But on the other hand, if you lower the temperature, Charles' law tells us what happens to the volume in that case. When you lower the temperature, the volume gets lower. So Boyle's law tells us that, because of the lower pressure, the volume should go up. But Charles' law says because of the lower temperature, the volume should go down. So they kind of contradict each other. And I would expect that the balloon, depending on how much lower the pressure is, we're not told, and how much lower the temperature is, we're also not told that. If you just imagine the effects kind of cancel off, maybe, it doesn't really change its size that much. And so Z turns into 2. Kind of tricky one there.